Our function is y equals x cubed minus 3x squared plus 2x plus 5. It is from the book Calculus 9th edition by Larson Edwards. This function is a third-degree polynomial which has 3 as greatest exponent of variables. This polynomial has 4 terms, including a third-degree term, a second-degree term, a first-degree term, and a term containing no variable which is a constant term. The largest power on any variable is the 3 in the first term, which makes this a third-degree polynomial with x cubed being the leading term. Also, the leading coefficient is 1 and the constant term is 5. In number 3, our chosen value is 2. In the graph, we can see the limit of the function as the independent variable approaches to 2. We can also see the different x and y values of the function as it approaches to 2.
Derive the function using steps 1 to 4. These are the steps to determine the derivative of the function. In step 1, we will replace x by x plus delta x and y by y plus delta y. Here we have y equals x cubed minus 3x squared plus 2x plus 5 as the function. We need to replace x by x plus delta x and y by y plus delta y. So, it will become y plus delta y equals x plus delta x cubed minus 3x plus delta x squared plus 2x plus delta x plus 5. For step 2, we will eliminate y using equation 1 and 2. In here, we need to eliminate y in step 1 and move the function to the right side and subtract the original function to the current function. So it will become like this. Delta y equals x plus delta x cubed minus 3x plus delta x squared plus 2x plus delta x plus 5. Subtract 2, x cubed minus 3x squared plus 2x plus 5. So we will compute the equation and combine like terms. The result for step 2 is 2x squared delta x plus x delta x squared plus x squared plus x squared delta x plus 2x delta x squared plus delta x squared, subtract 6x delta x minus 3 delta x squared plus 2 delta x. And in step 3, we will divide both sides by delta x. So, it is now 2x squared plus x delta x plus x squared plus 2x delta x plus delta x minus 6x, subtract to 3 delta x plus 2. So in step 4, we will determine the limit as x approaches to 0. So the result is y prime is equals to 3x squared, subtract to 6x plus 2. Derive the function using the standard formula developed in Lecture 3. So, as we can see, the function y equals x cubed minus 3x squared plus 2x plus 5 is derived by using the power rule and the derivative of a sum. The result is dy over dx is equals to 3x squared minus 6x plus 2.
In finding the slope, you will choose any points in your graph of your function. Here, I chose point 0 and 5. Since dy over dx is equal to m, which is the slope at point 0 and 5, m is equal to the first derivative of the function. We substitute the x value, which is 0. Therefore, our slope is 2. In solving for the equation of tangent line at points 0 and 5, the slope is equal to y minus y sub 1 over x minus x sub 1. Since our slope is 2, we will substitute m to 2, then equal to y minus 5, which is our y sub 1, over x minus 0, which is our x sub 1. We will then cross multiply. Therefore, our tangent line at points 0 and 5 is y equals 2x plus 5. In solving for the equation of the normal line at points 0 and 5, the slope is equal to y minus y sub 1 over x minus x sub 1. Our slope here is negative 1/2 equals y minus 5, which is our y sub 1, over x minus 0, which is our x sub 1. We will cross multiply, so the result is negative 2y plus 10 equals x minus 0. Therefore, the normal line at points 0 and 5 is x plus y equals 10. We will then graph the equation of the tangent and the normal line. We use a tool to graph our equation. As what you observe in the graph, these three lines intersect in the same point at 0 and 5.
As we solve for the first derivative, it will become 3x squared minus 6x plus 2. Since this is a quadratic equation, we can use the quadratic formula. Set A as 3, B as negative 6, and C as 2. As we are done identifying the values of A, B, and C, we can substitute these values to the quadratic equation. It will become negative times negative 6 plus minus square root of 6 squared minus 4 times 3 times 2 over 2 times 3. It will become 6 plus and minus square root of 36 minus 4 times 6 over 6. And lastly, it will become 6 minus square root of 12 over 6 and 6 plus square root of 12 over 6. The values of x are 0.423 and 1.5773. Now, we can solve for the critical points. Let x be 0.423, then substitute to the original equation, which is x cubed minus 3x squared plus 2x plus 5. Our y will become 5.385. Next, let x be 1.5773. Substitute again to the original equation. Our y will become 4.615. The roots of x are 0.423 and 1.5773. Therefore, the critical points are 0.423, 5.385, and 1.5773, 4.615. Concavity at point A, which is a maximum point, the curve is concave downward. At this point, the second derivative, if not 0, it must be negative. Similarly, at the minimum point, the curve is concave upward. At this point, the second derivative, if not 0, it must be positive.
In examining the function for maxima and minima, we will use our second derivative, which is 6x minus 6. Now, let x be 0.423 and substitute it to the second derivative, which is 6x minus 6. We will then arrive with an answer negative 3.462, which is y is a maxima since it is negative. Next, let x be 1.5773 and substitute it again to the second derivative, which is 6x minus 6. We will then arrive with an answer 3.4638, which is y is a minima since it is positive. The roots of x are 0.423 and 1.5773. Therefore, the critical points are 0.423, negative 3.462, and 1.5773, 3.4638. At point of inflection, we will equate our second derivative to 0. It will be 0 equals 6x minus 6. We will then combine the like terms, so we will transfer negative 6 to the left side. It will be 0 plus 6 equals 6x. We will then divide both sides by 6 so that the 6 on 6x would be cancelled. We will then arrive with an answer x equals 1. To get our y, we will use our original equation, which was y equals x cubed minus 3x squared plus 2x plus 5. We will then substitute x equals 1 to the original equation so that we will arrive with an answer y equals 5. Therefore, the points of inflection is 1, 5.